In this video, we will compare positive cosine x and negative cosine x using Taylor series expansion. We begin with the dataset of cosine, which is our formula, cosine of the x values from 0 to 6, and negative cosine, so our formula, cosine of the x values 0 to 6. But there is a negative sign, so we factor in the negative sign. And the Taylor series expansion, which is the summation of a times x to the power 2n, where n starts from 0 to infinity. So 0 up to infinity. Next, the coefficient a is equal to our formula minus 1 raised to the power the quantity n plus k. So this is k plus n, or n plus k. And the value of k is data validation, list of items, 0 or 1. 0 if it is cosine, 1 if it is sine. Now we continue with the denominator, that is divided by, this time it's gamma, 2n, so 2 times n plus 1, and enter. Now we can complete the Taylor series expansion. Our formula, SERIESSUM of the x values, that's x values raised to the power 2n. So 2n starts from 0, incremented by 1. And the coefficient a will be this range. And we'll chart this. Insert chart. And we use scatter chart. We don't need the title. Delete that. And show the trend line. So series. We also use column A as label. For the trend line, series, show the trend line, polynomial to the 6th degree. And for the label, use the equation. For the legend, position at the bottom. So here's our trend line and polynomial. So we have an error. Oh, this is 2. We change this to 2. 2n. So raised to the power 2n. 2n start from 0, incremented by 2. Now we are there. So next we change the chart. For the series, the point size will be maximum. Except for the expansion, the point size will be none. But the line thickness will be maximum. Now here's our trend line and polynomials of cosine and negative cosine. We'll calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power. Transpose 0 to 6. And the elements of the LINEST matrix. So array formula of the x values raised to the power 0 to 6. Now we can use LINEST to calculate the polynomial regression coefficient. LINEST data y and data x. Again, LINEST, that's for the expansion, data y and data x. And finally, the negative cosine. That is, again, LINEST dot y and dot x. Now let's compare. So here we have the polynomial. So coefficient of x to the 0, 1, 1, negative 1. So 1, 1, negative 1. Coefficient of x minus 0.0555, 0.0555. Coefficient of x squared, negative 0.0354, positive 0.0354. Coefficient of x cubed, minus 1.47 plus 0.147. Coefficient of x to the 4th, 0.117, negative 0.117. Coefficient of x to the 5th, negative 0.0201, positive 0.0201. And coefficient of x to the 6th, 1.07 times 10 to the minus 3, negative 1.07 times 10 to the minus 3. If I change this to 1, now it is negative cosine. These values are exactly the same. That's for negative cosine. If it is 0, then it is cosine. These values are the same, and their data sets are also, well, this approximates cosine. This completes the use of SERIESSUM, LINEST in the polynomial regression, and the gamma function to show the trend line and of the Taylor polynomials for cosine and negative cosine.